Good morning, Chemistry 20s. So here we are talking again about our VSEPR notes guide, and we left off last video talking about this example in the notes guide PF3, which ended up being a trigonal pyramidal. Looks like a little pyramid, okay, for its 3D shape. So I would like to show you guys an example of a molecule in real life that displays this particular shape, and that molecule is ammonia, NH3. So you can see in the blue dot there, that is a molecular model that represents the N for ammonia, and then the white little circles, well, those are the H's. And so you can clearly see that if I was to draw his Lewis dot structure, that he would have 1, 2, 3 bonding pairs, 1 lone pair, and you add those up, and that's how you get your total pairs of 4. So this little diagram, it doesn't show, but here's where the lone pair of electrons would be. And so how do we understand this shape? It's a 3-dimensional shape, right? And you can clearly see that you have the same plane. So these guys are in the same plane as the page, and we use a straight line for that. This guy is going away from you, and we use a little dotted line for that. And then sticking out towards you, that is how we use the little wedge. Okay, and so that's how we draw this molecule. It's very similar to PF3. Now we can look at another example from our notes guide, and we're going to look at an example that does not follow the octet rule. So now what do we do? Well, we're going to just kind of go through the same steps. Beryllium is our example here. It does not follow the octet rule. We're still going to count up the total number of valence electrons. We've got 1 beryllium, 2 chlorines, so 2 electrons for beryllium because he's group 2, he is a metal, and then our non-metal chlorine from group 17, the halogens. So total number of electrons, 16 electrons. So that's how many electrons we have to have in our diagram. We draw out our individual atoms, and we see that beryllium is going to be our central atom because he has more bonding electrons. He can make more bonds. He has 2 bonding electrons. Chlorine only has 1. So that makes beryllium our central atom. Okay, so let's start putting them together. So we've got 1 beryllium in the center. Our 2 peripheral atoms are chlorines. We make bonds to each of them, and that's just simply our 2 dots is 1 bond. Okay, so there's a bond, there's a bond. Now what? Okay, well, now we're going to fill our octets. So now chlorine has an octet, chlorine has an octet, 8 and 8, 16 electrons. That's our total number of electrons that we were supposed to have. Now what? Okay, now we're going to look at counting up our central atom. Again, central atom. Central atom's beryllium. 1, 2 bonding pairs. He has no lone pairs, right? There's nothing here. Nothing here, no lone pairs, 0 lone pairs. So 2, 0, 2. Well, now let's go to our chart, table 7, which I have told you guys, this is super important that we memorize this chart. It might even help you to draw it out on a piece of paper. So here we go, 2 bonding pairs, 0 lone pairs, total pairs of 2. This will be an AX2, and this is linear. This molecule is just in a straight line. That's what it means, linear. So how do we draw that guy out? Okay, so our finished product, AX2 linear, and then when we're doing our stereochemical diagram, Cl, straight line, Be, Cl. See what I mean? Linear, it's just a straight line. And we can see an example of that in, here's just a website that I found that has an example of BeCl2. So yeah, here is our Be. Here's a Cl, here's our other Cl, and it's a straight line. Okay, and that is an example of how we do a linear molecule, and this guy does not fit with the octet rule. Okay, so you guys keep working at this. If you have any questions, let me know. Good luck with that. You're going to memorize that chart. Okay, so michelle.ledeen@ghsd75.ca. Take care, and we'll talk at our next video.